Hello, my name is Joseph, and I will be doing a presentation over stoichiometry. Stoichiometry is a mathematical solution to find relative quantities of reactants and products in a chemical equation. What is involved when dealing with stoichiometry? You are given getting a specific amount of reactants, given a specific amount of products, and you are given the mass for either your products or reactants, and then you can use that mass using stoich to figure out the mass of the unknown substance that you know. Things need to be used when working out a stoichiometry equation. Molar ratios to solve for the molarity of moles of a substance. Number 2, molar masses. This is used in the molar ratios to find out what the molarity or mass of another substance is. And you will need to balance the equation for the products to equal to the reactants. So an example of that would be CH4 plus 2O2 gives you CO2 plus 2H2. So you have 3 moles on one side and you have 3 moles on the other. Here's a visual depiction of stoichiometry. So you have the mass of your given, and then you want to convert your mass or your moles using molar mass given, and then you take your moles given to find the molar ratio. That can be used to find the moles of the unknown, and then you can use that to convert back to your mass of the other unknown substance. Okay, steps in a stoichiometry problem. First, balance the equation given. So next, use the molar mass substitution to convert from a given mass to the amount of moles. We'll work a problem, an example, and we'll explain it later. Third, use a molar proportion. And last but not least, after finding the molar mass of unknown substance, convert the moles back to mass. Just like it was given, pretty much explaining what it told you before this slide. Okay, so what exactly is a molar ratio? A molar ratio converts moles of one compound into a balanced chemical equation to moles of another compound. Example, you have reaction between magnesium and oxygen to form magnesium oxide. Magnesium oxide is fireworks. So you have 2 moles of magnesium plus 1 mole of oxygen gives you 2 moles of magnesium oxide. So you have your mole ratios, you got 2 to 1, and then 1, 2, my bad. So here's an example of a stoichiometry problem. So you have 2 moles of Na, which is sodium, and you have 1 mole of Cl, which is calcium, if I'm not correct. No, chlorine. And that will give you 2 moles of, which is salt, NaCl. So you're gonna have, so you know that you're given for your NaCl is 25 moles molarity, and then you can find out. Okay, so you have 5.75 grams of sodium and 886 grams of chlorine, and you can use that to figure out that sodium by itself will have you just find your molarity and then multiply that by the mole ratio, and then you multiply by the molarity of what you're trying to find, and that equals 575 grams. And then you go and do the same thing, but instead of using the mole ratio from your sodium to your sodium chloride, you do from your chlorine to your sodium chloride, which is 1/2, and then you multiply that by your molar mass, and that gives you 886 grams of chlorine. Yes. Alright, let's work out a problem. Okay, how many moles are in 4.5 grams of glucose? Glucose is C6H12O6. Alright, so first step, you need to find out the molar mass of glucose, and then adding the weights of the individual atoms. Okay, so you get 6 times 12 atomic units plus 12 times 1.008 plus 6 plus 16 that gives you 180.1 AMUs, which is 180 grams over moles. And then it's pretty simple. You just use your given amount of grams and divide it by the molar mass of a given substance. So you're going to have 4.5 grams times 1 mole over what you found earlier, molarity, 180.1 grams, and that gives you 0.025 moles. Here is another example of a it's called mass-to-mass stoichiometry. Here is an example. Alright, so you have iron 3 oxide, also known as rust, can be removed from iron by reacting it with hydrochloric acid to produce iron 3 chloride and water. So that is your that's your equation. It's all balanced, so we're good. And then you ask what mass of hydrogen chloride is required to react with 100 grams of rust. So what you need to do is you need to convert the mass to moles. So you're going to have 100 grams of Fe2O3, multiply that by 1, which 1 gives you that many moles of Fe and that many grams. And then convert moles of Fe2O3 to moles of hydrogen chloride. So take your 0.0626 moles of that, multiply that by 6 moles of HCl, and that will give you 3.75 moles of HCl1 and 1 mole of Fe2O3. And then convert moles of HCl to mass of HCl. So 3.756 moles of HCl, multiply that by 36.46 molar mass, and that gives you 137 grams of HCl, 1 mole HCl. Here is another look at these steps. So this is like what you would look when you're trying to solve a stoichiometry problem. It's pretty much the same thing I just said, just like drawn out like more clearly, I guess. Well, that's pretty much it. I have covered everything I thought was necessary. I hope y'all learned something very significant that may help you in the future. Anyways, I hope you have a great summer, Miss A. I hope you enjoyed my project. Yeah. Pretty much that's it. I use most of my information from the book, from the chapter, but then I got some of the equation from online. And so I thank you for whoever this is. I do not own anything in this project. And have a good night.